So hello everyone, welcome back to our Python Programming Fundamental series. I hope all of you are doing well. And if you have been following the previous lectures, then today's lecture will be very interesting because today we are going to learn about two of the most important data types in Python. They are strings and lists. These two concepts are used in almost every Python programming. So whether you are building a simple calculator, a website, a game, or even an artificial intelligence application, you will be definitely working with strings and lists. So pay close attention throughout the lecture. So before learning something new, let's spend a few minutes revising what we have learned in the previous lecture. So revision is very important in programming. Programming is a subject where program is not a subject where we simply memorize concepts. Programming is all about connecting new ideas with previous ideas. So in our last lecture, we have learned about function composition. We understood that instead of writing one large function, we can divide our work into multiple smaller functions. Then one function can use the output of another function. This makes our program cleaner and easier to manage. So after that, we have learned about Python modules. We understood that a module is simply a Python file containing a reusable code. So instead of writing a same function again and again, we can store them inside modules and reuse them whenever we have needed. Then we learned different ways to import modules. We studied that the import statement, we learned how to import specific functions. We also learned about module analysis using the as keyword. Next, we explored the math module. We learned how Python already provides many useful mathematical functions like sqrt, pow, ceil, and floor. So instead of writing complex calculations ourselves, we simply use these ready-made functions. So finally, we spent most of our time understanding recursion, where we learned that recursion means a function calling itself. We understood that every recursive function needs a base case. We also wrote our first recursive program to calculate the factorial of number. Then we performed a complete dry run to understand how recursion actually works. So if you understand those concepts, then you are ready for today's lecture. So in this today's lecture, so according to the PPT, today's lecture contains two major topics. So the first topic is strings. So under strings, we will learn how to create strings, how indexing works, how to traverse through the string, how to perform string slicing, how strings are compared, and many useful string methods. We will also solve a few practice programs. After that, we will move to lists, where we will learn how to create lists, access elements, perform operations, and understand nested lists, practice programs, and finally learn about list comprehension, which is one of the most useful features of Python. So by the end of today's lecture, you will be comfortably working with both strings and lists. So now let's begin with our first topic called strings. So before learning how to create strings, let's understand what a string actually is. So the Python PPT defines a string as four important points. A string is a collection of characters and it's a compound data type, and strings are immutable in nature and they are ordered sequence. Don't worry if these terms sound unfamiliar. By the end of this section, all of them will make a string. So what exactly is a string? Let's begin with the simplest definition. A string is simply a collection of characters. Now, what do you mean by characters? Characters include letters, numbers, symbols, and even spaces. For an example, look at the word Python. This is a string. Why? This is made up of individual characters. The character P, then Y, then T, then H, then O, and finally N. Together they form a string. So here is another example. Hello world. Is this a string? Yes. Notice there are also space in between hello and world. Even the spaces are considered a character. Python counts everything like letters, numbers, symbols, and spaces as characters. So what about this? Let me have a program. 1 minute. Okay. So what about this thing? 1, 2, 3, 4, 5. Is this a number? Not always. If we write with inside quotation marks, Python treats is a string, not as a number. That's because Python only looks at whether the value is enclosed with quotes. We will see very soon and when we learn how to create strings. So what is a compound data type? And this PPT also says that a string is a compound data type. Now, what does that mean? Okay, let's understand with a simple example. Suppose I have only one character A. That's just one character. Now, suppose I combine many characters like apple. Now, instead of one value, we have multiple characters stored together. So, whenever multiple pieces of information are stored inside one object, we call it a compound data type. So, say a string doesn't store multiple characters together. That it's called a compound data type. So this PPT also says that the string are ordered sequence. So let's understand what does that mean. Suppose we write Python. Notice every character has a position. P comes first, then Y comes second, then T comes third, H comes fourth, and O comes fifth, and finally N comes sixth. The order never changes unless we create a new string because every character has a fixed positions. So Python says that the strings are in an ordered sequence. This idea will become very important when we study indexing in the next section. So what does immutable mean? Now, this is a new word, immutable. Don't worry, the word sounds difficult. The idea is actually very simple. Immutable means cannot be changed. Once a string is created, we cannot change the individual characters inside it. Suppose we create the string Python. Can each string change only the first character from P to J? No, Python does not allow that. And if we want a different string, we create a completely new string. And we will study this concept much better later. So when we discuss string operations, for now, just remember one simple rule. Strings are immutable. Where do we use strings? Now, before moving to the next section, let's understand why strings are so important. Almost everything you type on a computer is a string. Your name is a string, your email address is a string, your password is a string, your website URL is a string, your chat message is a string. Even the code you write inside the quotation marks is a string. Without strings, programs wouldn't be able to store or process text. That's why strings are one of the most commonly used data types in Python. So let's quickly revise what we have learned. A string is a collection of characters and it's a compound data type. It's an ordered sequence, and finally the most important one, the strings are immutable, which means individual characters cannot be changed after the string is created. Now that we have learned what a string is, let's learn how to create strings in Python using single quotes and double quotes and multi-line strings. Now we know what a string is. The next question is, how do we create a string in Python? Fortunately, create a string is one of the easiest thing in Python. So unlike some programming languages, Python gives us multiple ways to create strings. Let's learn them one by one. So creating strings using single quotes. The first method is using single quotes. The PPT says that string can be created using single quotes. Let's see an example. Let's have a name equal to Bharat. Name equal to Bharat and print name. The output will be Bharat. So very simple. So whenever we write inside single quotes, Python treats it's a string. So let's have another example. So if I have a variable called city and then inside the single quotes, if I have NA, and if I print it, it gives NA as the node. Again, Python understands that the string A is a string. So creating strings using double quotes. Now let's learn the second method. We can also use double quotes. So according to the PPT, single quotes and double quotes behave exactly the same. So let's write the same program. So instead of the single quote, let's have a double quote here. So name equal to Bharat. So we kept a double quote here, and if I print name, it prints Bharat. So did anything change? No. The output is exactly the same. Python does not give the special importance to single quotes or double quotes. Both create a string. So now many beginners ask, which one should we use? The answer is either one. Both are correct. Both create exactly the same type of objects. Most programmers simply choose one style and remain consistent. However, there is one situation where double quotes become very useful. Suppose our sentence contains an apostrophe. For an example, like I apostrophe am learning Python. So if we write text equal to I apostrophe am learning Python, and then Python becomes confused. Why? Because it thinks the string ended after I. So if this creates an error. So if I run it, it says in unterminated string detected on the line 1. So this creates an error. So instead, we simply use double quotes here. So let's have a double quote here, double quote, and then double quote here. So if we print the text and run it, it says, I am learning Python. Very easy, right? So similarly, if our sentence contains double quotation marks, we can surround the entire string with single quotes. So both quotation styles give us flexibility. So can numbers be string? Now let's clear one common confusion. Suppose a equal to 100. Is this a string? No, this is an integer. Now look at this. A equal to 100. Is this a string? No, it's a string. Why? Because the value inside the quotation marks, always remember the quotation marks change. Okay. So how Python interprets the value? So creating empty strings. Now, suppose you don't want to store any text. So we can simply create an empty string. Yes, it's very easy. So how we can create a empty string? So message equal to empty string, I mean the string and the print message. Nothing appears on the screen, but Python still created a string. It simply contains 0 characters. 0 empty strings are very useful while taking input, building text, or processing data. So now let's move to the another useful feature called multi-line strings. Suppose you want to store a paragraph or a poem or a multiple line of text. So can we write like this? Text equal to hello, welcome Python. No, Python does not allow normal strings to span multiple lines. So that's why Python provides triple quotes. The PPT explains that we can use either 3 single quotes or 3 double quotes to create multi-line strings, and Python preserves line breaks. So using triple quotes, let's message equal to 2 3. Hello, hello everyone. Welcome to Python programming, and then another line. Let's start today's lecture. After that, triple quote. Now print message. The output is hello everyone, welcome to Python programming, and let's start today's lecture. Notice something. Python prints the text exactly as we wrote it. The line breaks are preserved. That's exactly what PPT means. And using triple single quotes. Let's have triple single quotes here. 3. And then here I'll be having 1, 2, 3. And if I run it, see the output remains exactly the same. So whenever you use single triple quotes or double triple quotes, both are work perfectly. So why triple line quotes, I mean multi-line quotes used? Now you may ask, when I use a multi-line string, there are many situations. Suppose you want to display a welcome message, or when your program starts, or when you want to print a menu or a restaurant, or you want to store a paragraph or documentation. So instead of writing many print statements, you can simply use one multi-line strings. This makes our program look cleaner and easier to maintain. So let's check your understanding. Question number 1. Can a string be created using single quotes? Yes, absolutely. Can we use double quotes? Correct. Yes, we can use double quotes. So do both behave the same way? Yes, exactly. Which quotation marks are used for multi-line strings? Correct. Triple quotes. Either the single triple quotes or the double triple quotes are used. Okay. So let's summarize strings. We created string using single quotes or double quotes. Both methods behave exactly the same. If you want to store a multi-line of text, we use triple quotes. Python preserves all line breaks, making the multi-line string very useful for paragraphs, messages, and documentation. Now that we have know how to create strings, let's learn how Python stores them and how we can access individual characters using indexing. Now we already know what a string is. The next question is, how do we exactly work with strings? So in this section, we will learn everything you need to know about strings. By the end, you will be comfortably creating, reading, and modifying processing strings in Python. So creating strings, let's begin. Now let's learn one of the most important concepts, that is indexing. So the PPT says that the strings are indexed sequences. It's either positive indexing which starts from 0, while the negative indexing starts from -1. Let's understand this. Suppose we have a word called Python. The Python stores it's like Python, and each has an index 0, then 1, and this is 2, 3, 4, and then 5. So notice Python starts counting from 0, not 1. This is called zero-based indexing. Now, how do we access the first number? So we simply use, let's have a string a equal to Bharat. Print a of 0, and this returns b. So if you want to have second character, we simply use a of 1. Enter h. And if you want to have third, print a of 3, a of 2, then enter a. So very simple. The index tells Python that which character we want. So negative indexing. Suppose we don't want to count from the beginning. Instead, you want to read from the end. The Python allows this using negative indexing. So according to the PPT, the last character which has the index -1. So For an example, let me go to the PPT so you can clearly understand. Okay, so in this example, n is -1 and y is -2, h is -3, and then t is -4, 5 is, y is -5, and p is -6. Now, if we write, like for this example, Bharat, if we have a of -1, after, and then if we enter the program, it says t. And if I have print a of -2, it gives a. And similarly, the negative indexing is extremely useful if you want to access characters from the end without knowing the length of string. Now, let's see two common mistakes that the PPT mentions, that accessing a string outside accessing an index outside a string causes an index error. So using a non-integer index also causes a type error. For an example, our string contains only 6 characters. So if we write print a of 10, Python says there is no characters at the index 10, so it produces an index error. Similarly, if we write print a of 2.5, the Python produces a type error because indices must be integers. Okay, so it gives a type error. Notice the string indices must be integers, not float. So traversing through strings. This is the next topic which we will be seeing. So these were the things like specific characters to the positive indexing. Accessing a index out of range will causes an index error, and only integers are allowed as indices, and using a float or other types will result in a type error. So let's now traverse through strings. Now suppose instead of reading one character, we want to read each character. So the Python says that strings are iterable, which means we can use loops to access one character at a time. So let's have a loop. So here for ch in word, let me have a variable called word here. So word will be python, Python. So if ch in word and then print ch, then the output will be python. Notice this Python automatically moves from one character to the next. Think of it like a reading word from left to right. You don't need all the characters at once. You read one letter from the next, then next. So this is called traversal. So this is how traversal works. So this thing works exactly the same. So now suppose we don't want the entire string. We only want a part of it. This is called slicing. So the PPT defines that slicing or extracting a portion of a string using start and end indices, where ending an index is not included. So the general syntax will be, so 1 minute. So the general syntax will be string of start and then end. So suppose we have a word Python. Now if we print word 0 thing, and if we print it, it returns pyt. Why not pyth? Because the ending index is excluded. So remember these rules. So start is included and end is excluded. This is one of the most important rules in slicing. So another such example is 2 colon 6. So this thing goes from index 2 to index 5. So it prints THON. Again, Python starts at the index 2 and stops before the index 6. So let's see some other slicing which are there here. So here there is one thing called that the start value is not given, so by default it considers to be 0 and then the end value is 3, so it goes till second indices. So 0 which is A and 1 which is B and 2 is which is C are printed. And here in this example, we can clearly see that the start value is given, whereas the end value didn't even given here. So by default, the end value is considered as the last character in the string. So this starts from the third indices, which is the D, and goes till F. So D, E, F is printed. And this thing, if we have two columns and then the third column is called step value. So if we have the step value -1, so Python prints all the string characters in the reverse order. So I hope you understood string slicing. So okay, so let's move to the next part called string comparison. Now, can we compare two strings? Yes, the PPT says Python supports operators like double equal to, not equal to, less than, greater than, less than equal to, and greater than equal to for comparing strings, including alphabetical comparisons. So, let's try an example. Suppose if we have print apple equal to apple. So then what does the Python return? It returns true. So let's have another one example. Print apple double equal to mango. The output is false. The Python compares the characters one by one. And this is so useful while sorting strings alphabetically. So there are other things like string operators. So when like greater than and less than symbol. So these two compares all the characters. But if at the one time we can if the Python can conclude that one character is greater than or less than the other, so the Python immediately stops there itself and prints the accordingly value. So let's have one example here. So here I'm having print A, B, C double equal to greater than A, D, and then A. So even though the first character is same, and the third character is less than, the third character is less than the before one, Python generally prints the value which is there in the second is greater and the first value is lesser. So this prints false. But if we have this thing and instead of greater than, if we have less than, and if we print, it gives true. So this is what string comparison is. So let's see it further. So Python supports several operators for string comparison, including equal to, not equal to, less than equal to, greater than, and greater than equal to. These operators allow both equality and lexicographical, that is, alphabetical order comparisons, so which is useful when sorting or arranging strings. So now let's see some common string methods. The Python provides many built-in methods to work with strings. Let's look at the most useful one called len. So len returns total number of characters. Okay. So if we have a string called Bharat and if we give print len of z, which is string, it gives 6. So total 6 characters are there in the variable value called Bharat. So let's look to the next one called upper. So upper converts everything to uppercase. So let's see that too. So here in this example, upper method converts all characters to uppercase, whereas lower method converts all characters to lowercase. So here s is equal to hello world, and if we want to print s dot upper, it prints hello world where all the characters are in caps, and the s dot lower prints all the characters in small. So the next method is strip. So strip removes the extra spaces from the beginning. So here we can clearly see that in this string there are some spaces in the front as well as in the back. So these extra spaces are removed using strip. So notice after printing yes, we can clearly see those trailing spaces are removed. And the next one is called replace. Replace is replaces the one word with another word. So here in this example, we have Python is fun. When we use method called s.replace fun, comma awesome, the fun subscript, the sub string gets replaced with awesome substring. So the output will be, instead of Python is fun, it prints Python is awesome. So I hope you understood this thing. So let's go to the another main method called capitalize. So capitalize converts the first character of the string to uppercase and the remaining characters to lowercase. So if we have a text dot, if we have a string called Python programming, and if we print text dot capitalize, it prints Python programming with the P caps. The rest all values are in the small value. So next, let's see about split. So split breaks one string into multiple parts. So here by default, split has an delimiter called space. So this thing separates Python and then is and then easy. So if we have z equal to Bharat, is, yeah, PRO, GRAMMER. And if we end the string, and if we want to print z dot split, and then inside that, if we have comma as a separator, what does it do? It prints Bharat, is, a programmer. So understand, instead of just space, we can also use comma here. So this thing will be sometimes useful when we convert from string to list. So forget about this thing for now. We will see about this thing in the later part. So the next method is join. Joins multiple string into one. So here we can say Python is easy is a string. So if you have a string dot join words, so this thing gets joined with in between of every elements present in this list. So Python is easy. Python hyphen easy is printed. So the next one is find. So find searches for a word and returns its position. So here in this example, text is going to learn Python, and if we want to find text.find Python substring, so it generally does like 0, 1, 2, 3, 4, then there is a space, and after that the Python substring starts. So it returns 6 as an index value, and if it is not found, it generally does -1. Okay, so the next one is count. So counts how many times a word appears. So in this string there are values, there are characters like apple and mango. So if you want to count how many times this apple substring appears in this text, we simply have the string name, the string variable name dot count, and then the substring value. So here for this example, the output is 2. The next one is called starts with. So starts with check whether string begins with a particular word. These methods save programmers lot of time because Python already provides them where we can simply call the method and instead of writing our own logic. So the next thing is called membership testing. So before that, there are some other few methods where we can use strings. So there are thing called index where it returns index of a substring or is alnum, is alpha, is ASCII, is decimal, is digit. So these words can easily be understood by yourself and have a go through about these, and since time is less, we'll be discussing about the membership testing. So here, the the PPT also introduced membership testing. Suppose we want to know whether a word exists inside another string. Python provides the in keyword for an example. So here, in this example, yes equal to Bharat, print the in yes and print rat in yes. So it prints the first thing. Yes, it's correct. But this substring, capital R, even though we have small r here in this string, the capital R does not have. Now understand, Python is a case sensitive language, so it returns false as an output. So I hope you have understand what it is. So here it is very useful, especially while validating user inputs. So finally, the PPT gives several practice programs to strengthen our understanding, such as creating a string using the first, middle, and last character, reversing a string, splitting a string, counting vowels, removing nth word character, and removing duplicate characters. I strongly recommend to pause the video, try solving these problems on your own, and only then you can check your solutions. So programming is learned by writing code, not just watching videos. Among these problems, I'll be I'll be trying to solve one or two two problems. Okay. So let's try it. Okay. So let me open my IDLE. So the first problem I will be trying is count number of vowels. You already know what are vowels. So vowels are nothing but A, E, I, O, U and capital A, capital E, capital I, O, U. Suppose I have a string yes with some I am Bharat, I am from Tamil Nadu and I am a programmer. So if I have a string called this and if I want to calculate how many times the vowels appear, let's have a first count equal to 0. Then for I in yes, if I in vowels, we saw a membership thing. Okay, so the first character I will be checked here and each time it appears. So count plus or equal to 1. So after that, print count. If I save it and run, it gives 18. So in this string itself, count appears 18 times. So I hope you have understood this thing. So let's try another one example. Another one program. The program is, let me look at the program to solve it. So remove duplicate characters. Similar logic. So here I'll be using one concept called string concatenation. So first I'll be having a string I am Bharat. Okay. So next I'll be having S1 with a string, an empty string. Okay. So now I'll be having for I in yes. If I equal to equal, if I in S1, let's have like if I not in S1, S1 plus equal to I. So now I'll be printing S1. So if I do, it gives I space AM, B, H, or T. So these are unique characters. So we just removed the duplicate ones. So I hope you have understood the string operations, some basic concepts of strings. So let's summarize today's what we have learned is how to create strings, use single, double or triple quotes, perform positive and negative indexing, and traversing through strings, exact strum strings, and using slicing, compare strings, okay? So use important strings methods, perform membership testing, and finally, we looked at practice programs to strengthen our understanding. This completes everything related to strings. Now, let's move to the second major topic of today's lecture, which is lists, where we will learn how to store multiple values inside a single variable. Now we have completed our discussion on strings. Let's move to another important Python data type called list. So if strings allow us to store multiple characters, list allows us to store multiple values. These values can even be different data types. Lists are one of the most powerful features of Python. You will use them almost every day while writing programs. So what exactly is a list? Let's begin with the definition. So according to the PPT, a list is an ordered collection where it is mutable and it stores multiple values. Let's understand each point one by one. So suppose I want to store 5 student marks. So without list, it would be marks equal to 85, mark 2 is equal to 90, mark 3 will be equal to 76, and so on. So looks fine. But what if there are 100 students? We will create 100 variables. No, right? That becomes very difficult to manage. So instead, Python gives us lists. Now, all those marks can be stored inside one variable. Much easier and more only one variable. So multiple values. So that's why lists exist. Think about your student attendance register. Does the teacher create one register for every student? No, right? One register. Instead, there are many student names. A Python list works the same way. One variable, many values. So the PPT says lists are an ordered collection. That's what because ordered means. Let's suppose we create a list fruit equal to apple, orange and mango. Notice the order apple comes first, the mango comes second and the orange comes third. The Python remembers this order. So whenever you print the list, the values appear in the same sequence. This is why the list is called an unordered collection. Mutable. Now here comes the new word called mutable. Remember strings were immutable. That means we cannot change individual characters. The lists are opposite. So lists are mutable. This means we can change, remove or add elements after creating the list. For the example, suppose we have fruits equal to apple, mango or orange. So let me have it. So later I decide to replace orange with banana. Can I do it? Yes. List allows us to modify the contents. So that's why they are called mutable. We will see how to do this in a few minutes. Lists can solve different data types. The another powerful features of lists is that they can store different types of values. For an example, data equal to Bharat, 99, 9.59, true. Notice what happened. The first value is a string, the second is an integer, the third is a floating point number, the fourth is a boolean value. All of them are stored inside the same list. A very few programming languages make this so easy. Now, let's see how to create a list. The PPT says lists can be created using square brackets, the list constructor, or by repeating elements. The most common method is square bracket. Example, numbers equal to 10, 20, 30, 40, 50. Simple. Now let's create a list of names. So here B equal to apple comma banana. So again it's very simple. So creating a empty list is very simple. We just keep square brackets. So right now the list contains nothing. Later we can add elements to it. This is useful when we don't know how much data a user will enter. So internal representation of list. Now there is an interesting concept. So the PPT explains that the lists do not store the actual values directly. Instead, they store the reference or memory address to those values. Don't worry, don't need to understand the computer memory in detail. Let's simplify it. Imagine your mobile phone and has your contacts app. Does not contain the actual person. It only stores information about the person, like their name, the phone number. Similarly, a list stores references to the object, not the object itself. So for the beginners, this is enough to understand. Later, when you study data structures or memory management, you will learn this concept in a greater detail. Now, suppose you have a list, so which is 10, 20, 30. And how do we access a particular element? So the PPT says use zero-based indexing like strings. So this same thing happens here. Now, if we have a of 0, it prints the first element which is 10. And if it is a of -1, it prints the last value which is -1. I mean 30. So there are some common beginner mistakes. Now suppose our list contains only 4 elements, and if we can we write print a of 10. No, the Python produces an index error because there is no element at index 10. So always remember the index must exist within the list. So let's check your understanding. Suppose we have numbers 5, 10, 15, 20. So what is number of 0? Correct, it's 5. And what is numbers of -1? It's 20. So can list the store different data types? Yes, absolutely. So are lists mutable or immutable? Correct, lists are immutable. Excellent. So let's summarize here what a list is. So list is an ordered collection and it is mutable, and also it stores multiple values inside one variable. So lists can core multiple data types together. We learned how to create lists, how Python stores references to objects, and how to access elements using positive and negative indexing. Now, let's continue working with lists, where we will learn list methods, list slicing, traversal, nested lists, and there will be some practice programs. And finally, we'll be having list comprehension, which is one of the most powerful Pythonic features of the language. Now we know how to create a list, and we also know how to access its element. Now the next question is, what else can we do with list? So can we copy it? Can we sort it? Can we reverse it? Can we search for the element? So the answer is yes. Python provides many useful list methods. So let's learn the most important ones. So list copy. So first we have the list something. Let's have a list, okay? So let's have a list. Apple, mango, and orange. And if so, now I want another list containing the same elements. So instead of writing everything again, the Python provides copy method. For an example, L1 equal to L dot copy. So if I print L1, it prints what and all elements does L1 L had, it prints those values. Think about photocopying a document. The original still exists. The photocopy also exists. Similarly, copy creates another list. So searching an element. Suppose your list contains many values and you want the position of a particular element. So Python provides an index method. Okay, so let's run it, and these are some strings. And if I have L dot index mango, it returns, let me run it again, L dot index mango, and it says 1. So the Python tells us the mango is present at the index 1. It's very useful while searching for the data. Now, reversing a list. Now, suppose you want to reverse the order of elements. So instead of writing your own program, Python already provides the reverse method. So it's very simple. L dot reverse, L dot revse, then L. So the order is reversed. Notice the first element becomes the last element becomes the first. Now, suppose we have students' marks like M 10, comma 55, comma 64, comma 12, comma 87, comma 07. So these are in a random order. So can Python arrange them automatically? Yes, which is using sort method. Okay, so how does it do? M dot sort, and then if I have print M, the things are arranged in an ascending order. Now everything is arranged in ascending order. Sorting is one of the most commonly used operations in programming. So whenever you see leaderboards, students ranking, or highest mark, these are things where sorting is happening behind the scenes. Now the next thing we'll be seeing is list slicing. So list slicing is the technique used by extract of a portion of a list by specifying the range of indexes. Now suppose we don't want a complete list. We only need a part of it. Just like list strings, list also suppose slicing. The general syntax is list, name, start, end, step. Suppose we have a string, we have a list of fruits. Okay. So if I want to print fruits from the second in element, the second index to the fourth one. So the Python gives output orange, mango, and grapes. Okay, so the next output is if we want to have all the items from, like, it's like creating a copy of the entire list. We'll be having no values at the both ends. So if you want to get items before or after a specific position, you can if you want to retrieve all those values, we can use these two things. So 2 and then column, and if we leave the top one blank, it considers the last value and starts to go from the second index till the last index. And if we have beginning is empty and the end is given, it starts from the beginning and goes till the the second index, which is 1, 2, and 3. So if we want to get items between positions, it's very simple. Start from first index and go till third index. So 0, 1, 2, 3. So what does it print? It prints 2, 3, and 4. Okay. So if you want to get that spare items at specific intervals, like jumping with two statements. So first it will start from 1 and it prints 3 and 5 and later 7 and then 9. So this can be done with this statement. And if we want to have two elements jumped, we'll be using this thing. So I hope list slicing is understood. So unlike indexing, list slicing does not raise an error if a specific indices are outside the list range. So here it started from the 7th index and goes till the 15th index. But there is nothing called 15th index. There is only called 8th index. So the Python gives output 8, 9. what if both the index, I mean both the values are out of range? So the Python prints nothing. It's just it prints just a blank list. Okay, so let's see. Suppose instead of reading one element, we want to read every element. So here we use a loop. So for an example, here we have A equal to apple, comma banana, comma cherry. So here for item in A, we have to print item apple, banana, cherry. So the output will be like this. Okay. So here, or else if we have a list, I mean list called num equal to 10, comma 20, comma 30, comma 40, and for num in numbers, print num. So if I save it and run, okay, it prints 10, 20, 30, 40. The Python moves through the string list one element at a time. This process is called traversal. You will see list traversal very frequently while solving programming problems. So now let's learn one of the most interesting part, like another interesting part in this Python lecture, which is called nested list. The word nested means something inside something. Suppose we create this list like A of 1 comma 2 and then 3 comma 4. So in this, if we print A of 1, it prints the entire list which is there in the first index. This is considered as the first and this is considered as the second index. So this is 0 and this is 1. So within that, this is 0 and this is 1. And for this first index, the 3 is 0 and 4 is 1. So if we want to print list of 1 and 0, this is how you can access the nested list. So how it is done? A of first index, which is 3 comma 4, then 0th index. So it returns the 3 value. So the output is clearly visible here. So I hope you understood this thing too. So think about a classroom. The classroom contains rows and each row contains students. Similarly, the main list contains smaller lists. I mean, the nested lists are commonly used to represent tables, matrices, game boards, and spreadsheets. Suppose we want a number 5. We simply select the second list and then we select the element. So output is 5. Notice we use two indices, once for the row and another for the column. Now the Python provides few practice programs. This include finding the total sum of a list, calculating the average, finding the product of all numbers, counting even and odd numbers, and identifying the longest string inside a list. I strongly recommend that you solve those problems yourself. Watching programming videos are useful, but writing code yourself is what actually improves your programming skills. Okay, so let's solve like two problems which are given here. So the first problem we'll be solving is calculate total sums of a number in a list and find the arithmetic mean. And then let's try to solve this thing. Given a list of integers, iterate to the items and count how many are even and how many are odd. So let's try both of the programs. And let's solve the first one by the way first. So the first problem is, if I have a list where there are some numbers called 40, 55, 64, 78, 112, 13, etc. These are some numbers and I want to print sum of all those lists. So I'll be having S10 for I in A, S1 plus or equal to I. then print S1. So what does it do? It prints the sum values, which is 292. So the first problem is successfully solved. The second problem is, before in this, there is one another thing specified that we need to also find the arithmetic mean. So arithmetic mean is nothing but which is length of A. So number of numbers are A. So this thing gives 36.5 is the average value. So the first program is successfully done. The next program is, if I have the string 1, 13, 15, 48, 47, 12, 8, 54, 16, 95, 94 something. So these are some list of values. Here I need to print how many even numbers are there and how many odd numbers are there. For this, we simply use the traversing concept, which is nothing but I'll be having C1 equal to 0 and C2 equal to 0. And C1 meant for counting odd numbers and C2 meant for counting even numbers. For I in A, if I modulus 2 equal to 0, then C2 plus or equal to 1. Else C1 plus or equal to 0. 1. So I'll be having an else block and print count even numbers. C2 print count of So if I save it and run, it gives count of even numbers as 6 and count of odd numbers as 4. So this is what the program actually is. If you understand the concept very well, you can easily code the problems. So now let's learn our final topic of today's lecture, which is called list comprehension. The PPT defines that list comprehension as a concise way to create new lists from existing iterables, making the code cleaner and easier to read. Don't worry about the definition right now. Let's understand with an example. Suppose we want a list containing the squares of numbers from 1 to 5. In the traditional method uses a loop, but list comprehension allows us to do it in just one line. For an example, let me have a square, sq equal to x multiplied by x for x in range 1, 6. And then if I print xq, it prints 1, 4, 9, 16, 25. Looks amazing, isn't right? Only one line, yet Python creates the complete list. There are also some few more examples where this code uses list comprehension with the condition. So for value in value in a range, for value in lane A, if value divided by 2 is equal to 0. So this prints all those even numbers. So the output will be 2, 4, that's it. So here, then another such example is list comprehension is used with a condition to create a new list of lists with numbers greater than 10 from the list B. So we already have a list called B, and the resultant list gets the value like variable for value in B if value is greater than 10. So it prints 6, 12, 18 and 20 as an output. So creating a list from a range. So this thing only we saw well in that example. And we can also print nested loops A list of coordinate pairs of 3 into 3 grid can be generated by combining two loops inside a list comprehension. Okay, so we can also flatten list of lists using nested list. Okay, now don't worry if this syntax looks unfamiliar. Almost everyone finds list comprehension confusing for the first time. As you practice, it becomes one of the favorite features in Python. Professional programmers use it frequently because it makes our code shorter, cleaner, and more readable. So let's revise everything from for about list. So are lists mutable or immutable? Lists are mutable in nature. So which method sorts a list? It's sort method. So which method reverses a list? Reverses the order of elements. It's reverse. So can a list contain another list? This is called a nested list. So what is list comprehension? Correct. It's a shorter or a cleaner way to create lists. So with that, we have completed both major topics planned for the today's lecture. Today, we began with strings and we learned how to create strings, perform indexing, traversal, slicing, and comparison and use that important string methods. After that, we moved to list, where we learned how to create lists, access element, use string methods, perform slicing, traverse lists, work with nested lists, solve practicing programs, and finally understood list comprehension. So, congratulations, you have successfully completed another important lecture in our Python programming fundamental series. So, which is strings and lists are one of the two most frequently used data types in Python. You will continue to use them throughout your programming journey. So don't just watch this lecture, open your computer, type some programs, change the values, experiment it, and solve the practice questions given in the PPT. Okay? So programming is learning by coding, not just by watching. In the next lecture, we will continue our Python journey with more exciting topics and practical programs. Until then, keep watching, keep learning, keep enjoying the coding. So thank you for watching and I will see you in the next lecture.